All right, let me show you how to add these two vectors using only a calculator and these angles like this. Okay. The first thing we're going to do here is we're actually going to find the components of both of these, right? So I'm going to call this guy vector A. I'll call this guy vector B, right? And ultimately what we want to do is make a little table here. A, B, we want to know what A plus B is, right? And then I like to be very methodical about this. I like to make little tables of things and just add these numbers up because it's really a pretty simple idea, but the devil is in the details. You just mess one little thing up, right? So this will be the X component. I'll put the Y component there. Okay, so let's see. Let's look at this guy here. This guy, the first step is we want to find the components of this. Let's draw the components. So there's that component right there. You see that? And it goes up there. It goes up, and then it goes to the right. So this guy's going to have actually two positive components, right? Here is my adjacent side because it touches that angle. Here is my opposite side, right? Now notice that I drew those components from the tail to the tip. And that's what you're going to do. And I drew them around the angle that's given. So that's 42 degrees. And then the magnitude is always talking about this hypotenuse. So 13.4, in this case, meters, right? Okay, now, this opposite side here, opposite sides are always the hypotenuse times the sine of the angle, right? So that's going to be 13.4 times the sine of 42 degrees. So let's do that. Now, just for kicks, right? Hit the mode button on your calculator. Do yourself a favor before you take this test, before you do this. Hit the mode button. Make sure you are in degrees, clear. Try doing the sine of 90. I just typed sine 90, right parenthesis, enter. You should get 1, okay? Then you're in degrees, right? Because you really don't want to be in radians for this when you're using angles and degrees. Okay, so literally I type 13.4 sine 42, right parenthesis, enter. I get 8.966, right? And then the adjacent sides are always hypotenuse cos, whatever the angle is, right? So that's going to be 13.4 cos 42. So 13.4 cos 42, right parenthesis. And that's 9.958. Okay, so we drew the components. That's the first step. Go from the tail to the tip. Use arrows, so go up, and then from there, go to the right. Okay, the next step is find the lengths of the sides. We've done that, right? The next is to decide if these are X or Y, and if they're positive or negative. Okay, so my opposite side right there, that's my opposite side. That is definitely in the X direction because it's horizontal, right? And since it's to the right, it's definitely positive X. And my adjacent side, this being the adjacent side right there, it goes up and down. So it's definitely the Y direction. And since it goes up, it's definitely positive. So now I'm just going to write these guys in here. A is 8.966 meters in the X direction and 9.958 meters in the Y direction. Okay? So I'm done with that one. Okay, so let's draw this guy here. Okay, this guy is, let's draw them. I'm going from the tail of the vector to the tip of the vector. So I have to go left first. I have to go left first because I want to draw it around that angle. So there it is. So that's a leftward component, and then I'm going to go down here. Okay, so I'm to the left and I'm down. This is my adjacent side. And this is, of course, my opposite side. Okay? And now I'm going to do the same thing. I'm going to find these sides. Where should I do it, though? I guess I'll just do it here. Okay? So my adjacent side is equal to the hypotenuse. Let's see, it's 6.12. Oh, and that angle is 11.3 degrees. Is that little guy right there. So it's going to be 6.12. And since it's the adjacent side, it's cos, right? Cos of 11.3. So 6.12 cos 11.3 right parenthesis equals 6.001. Okay, and then my opposite side, that's this little bitty side there, should be small. This should be a small side. Okay, that's 6.12 sine of 11.3. So let's try that. 6.12 sine of 11.3, 1.199. 199. Okay, so now we got to decide. Here's my adjacent side. It goes to the side, goes to the left. It's definitely an x direction because it's horizontal, right? It goes this way, not this way. Okay, and then it's to the left, so it's definitely negative. This guy here goes up and down, so it's definitely a y direction, especially since that one is the x, right? Okay, and then it goes down. This vector goes down, right? So that's a negative like that. So now let's put these guys in. Negative 6.001 meters in the x direction, right? And then negative 1.199 meters in the y direction, okay? Now we're looking pretty good here, right? Basically, all we have to do now is add these guys. But first, before we do that, let's just double check. This is an adorable angle, so the opposite side, in this case the x, should be smaller than the y. X is smaller than y, that's a double check, right? This guy ends in the first quadrant here, so it's positive x, positive y. They're both positive, that's good. Okay, this guy here, the opposite side, in this case the y component, is small, and the adjacent side is big. Small and big, that's good, right? And then this is the third quadrant, so it's negative x, negative y. We go to the left, we go down, left, down. So that's good. It's a good sign. The other good sign is that, of course, we're getting what's on the spreadsheet down here, right? Okay, so now the next thing to do is to add. You got this plus this, and you get the x component of the sum. So I'm going to go 8.966 plus negative 6.001. And I get 2.965. In the x direction, of course, that's positive, right? And then I go 9.958 minus 1.199. And I get 8.759. And that's meters in the y direction. So that is the sum in component notation. It'd be this in the x direction and that in the y. But that's not what it asks us to do, right? What we need to do is we need to write this as an angle magnitude vector. So to do that, we just have to draw a picture of it. And that's what that little plus thing is for. You're supposed to draw it on there. If you can't, that's fine, right? So what I'm going to do is I'm going to draw the x first. The x is to the left. Oops, whoa, 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 whoa. What am I doing? I'm going to draw the x first, and the x here is to the right. Okay, so let's draw that guy. Okay, to the right. And then I'm going to go up, and I'm going to go up more than I went to the right. It doesn't have to be perfectly to scale. Just make smaller components look bigger. Notice I drew to the right, and then from there I went up. You're going to do the same thing. You always draw your x, then draw your y. Doesn't matter. I mean, you could do it the other way. You could draw y and then x. Doesn't matter. So that is the vector, that sort of wobbly thing right there. I'm going to find this angle. You should always find the angle with the tail of your vector. I'm going to find this magnitude. So that angle right there, angles in general are the inverse tangent of the opposite over the adjacent. Okay, this angle here, theta, is the inverse tan of the opposite, which is the 8.759 divided by the 2.965. Okay, so that's the length of this side, 2.965, right? This side here is 8.759. So let's do that. Inverse tangent, so second tan of 8.759. Now, some calculators, if you don't get a left parenthesis, put this in a left parenthesis. Same with this thing, right? Put that thing in that's the same thing, right? Put it in a left parenthesis. Otherwise, it will take the inverse tangent of the first number and then divide the result of that by the second. So I go inverse tangent, left parenthesis, 8.759 divided by 2.965, right parenthesis, I get 71.3 degrees. Okay, so that's my angle with the x-axis, which is, of course, the same angle that I get there. You can ignore that. That's just if you found the other angle, that's what it would be. Now, to find the magnitude, which is the hypotenuse here, the magnitude is the square root of 8.759 squared plus 2.965 squared. And be very careful. If you have negative, like if one of those was negative, don't put the negatives in there. Square root of 8.759 squared plus 2.965 squared. If it doesn't do this to your numbers, like put a square root over it, you have to put parenthesis and then an end parenthesis. I'm getting 9.25 as my magnitude, right? So this is my final answer. This is 9.25 meters at an angle of 71.3. That angle there is 71.3 degrees above the x-axis. There you go. So step 1, break it into components and put it in a nice table. Step 2, add x to x, y to y. Step 3, draw a picture of your resultant vector. Find the hypotenuse, that's the magnitude. Find the angle with the tail, that's your angle. Label it, draw a picture of it, label it. Make sure your vector is arrows. Okay, I will reject triangles. This will not get full credit. Okay, it needs to have tips, arrow heads on them, yeah? Okay, that's the bare minimum. It's better if you draw little arrows on the components too. I think we're good. Are we good? I think we're good. Is there anything else to say? I don't think so.